Installing a set of off-the-shelf headers on your muscle car is cool, there's no doubt about it. But you know what's even cooler? Building a set from scratch. So in this video, we're going to take you behind the scenes and show you the secrets of how we build a quality set of stainless steel headers. Although calling these secrets is a bit of an overstatement, they're just tips, tricks, and methods we find most useful to achieve the result we're looking for. There is one secret that only someone who's built a set of headers or someone who's paid for a custom set of headers knows, but we'll get to that later.
So first of all, I'm going to show you all the parts we use to build the set of LS headers. We use 180-degree mandrel bends, and I have two different sizes here. This is a 2-inch centerline radius, which gives you 4 inches across. And then this one is a 6-inch, or a 3-inch centerline radius, and it's 6 inches across. And what that does is they just about fit inside of each other, depending on availability. I would prefer probably a 3.5 inch on the larger one, but I wasn't able to find any at this point. One thing, if you want to build your own set of headers, I'm thinking about starting up a kit for these. We'll have all the parts on our website. So we use these 180-degree mandrel bends. Everything we have here is 304 stainless steel. I know there's been some debate. I've talked to some exhaust guys before, and they like 410 stainless. The problem is with 410 stainless is it's got a lot of iron in it and tends to rust. Coming from the industrial world, for me, 304 stainless is far superior. It doesn't oxidize as easy. It holds up to heat well enough for what we're building, and you know, in some turbo applications and all, there are some better stuff out there, but for what this is, naturally aspirated, the 304 is awesome. We'll carry that all the way out the back. The mufflers and everything are 304 stainless. Let me go back and talk about our flanges. A lot of different flanges out there. These are a really nice piece. This is a cast stainless piece, and they're just super lightweight. They're easy to weld up. And they fit in LS wonderful. They're nice and flat. It's a two-piece, so that you can actually get a little better fit when it bolts to the head. They flex a little bit, and but we always try to stay with we either use these or a really nice 3/8 thick flange that it keeps it nice and flat, and you don't have header leaks. It always seems to be a headache. We'll bolt the flanges on with ARP bolts. That's pretty much all we do. We either use these or we use the studs. These, of course, are metric and with the 3/8 flange drive. So we come from the flange, we go to the tubes, and then these are actually an 1 7/8 primary tube. That works for most, I'd say up to probably 1,000 horsepower. The 1 7/8 is good on an LS engine, and it fits really well to the size of the ports on an LS. GM nailed it when they made the round ports, so we're not having to do something weird. In fact, let me got these cool pieces in my toolbox. In the past, I've had some really odd applications that we have had to make our own stub outs out of the flange. These LS, they just go right into it. It's nice, but sometimes you get an odd shaped port. So we've made up dies, and we actually press and make our own stubs to come out of the header flanges, so that these are available. This one's like a D shape. I think I used this on a nail head. Those are just some different ideas that you can do. Then moving on back, we'll bring all those header tubes back to a collector. So this is our collector. There's some different kinds of collectors out there. There's a merge type where you'll take bends and saw them off so that they all kind of blend together, and then you put another tube to it. I prefer this method, which is basically a pressed steel. They take a cone and press it and form this shape. And what that does is you have your 4 header tubes coming together, the 4 primary tubes, you'll have 4 of these coming together in a group, and it makes a square, and you'll be seeing that here shortly. This is our collector. Then inside of that collector, this makes our little cone. These 4 pieces go together, and this is our tool to hold them in place. What I'll do is I'll hold them together like that and tack it up. And what this does is it guides your exhaust gas. So when you have those 4 tubes together, on the end of that, there's like a little, almost like a little diamond shape. And what that does is it goes inside there at that point so that it funnels all of them into what we call the collector. It's collecting all the gases from all 4 into this 2.5 inch diameter tube. These help guide it into it. There are some other stuff available where you just have the star and you basically fill that void. So there's, maybe I can mock it up here. So yeah, if you have these 4 together, you can see there's this little diamond star-shaped hole in the middle of them. And what we'll do is we'll tack all 4 of these together and weld across this end, and then you could either put the star on flat on here, but what we prefer to do is do this piece that fits here, and that just helps guide it all the way into the collector. And then from the collector, we want to actually build this car with a 3-inch exhaust all the way out the back. And so what we've done, and I've learned from working on NASCAR stuff, is it merges together and creates a venturi here. So we're necking it all the way down to 2.5 inch, and then we're using this cone adapter that tapers it back up to 3 inch. And what that does is when they come together, they're coming out of the head that's got a lot of velocity, and when they merge together, it combines and it speeds up as it goes through this 2.5 inch, because you've got all 4 of them pushing at once, but it's pulsated. So when the pulses go through here, it speeds up. You can imagine that there's a certain amount of volume of air that has to pass through here. And when it necks down, it speeds up. So you've got this volume of air, which still has kinetic energy pulling, and it creates that vacuum and helps evacuate your cylinders. So we do this on a lot of our headers.
Enjoying the video? Consider subscribing and check out some of our other videos. If you're new to Old Anvil TV, this channel offers a unique look into the world of building custom, high-end classic cars and trucks. We'll show everything from designing and fabricating a custom chassis all the way through to the finished build.
So the next thing I want to show you is all the tools we use. There's all kinds of things you can use. I mean, I guess we started out with rocks and hammers, or rocks and sticks. So we've kind of moved up from there, and now we've got some really nice stuff that's specific to building headers. So we started out with these ICE Engine Works mock-up, and what I have is these snap together, kind of like Legos. They have a nice D10 in there, and they pop together. And then they have this really nice little arrows that allow you to get them perfectly straight to one another. And I think these are 1-inch increments along the back side. And they have each one is labeled. So this one's a 3-inch center line, 1 inch long. So, but it matches up perfectly to the 3-inch center line piece. And then we also have another set that is matching up to our 2-inch center line. And then they also sell straight ones, and they're also in a 1-inch increment. And they also have the things to line them up so that you can kind of gauge where you are. So if you do that, then you can also take and turn them, and you can kind of measure and see where you are to know what kind of angle you have to have. Or you can put reference marks on it, and you can see on some of these, we have some marks that have, it's like that's where we wanted it to turn. So then we go cut our piece, and we have the marks on our template. So when we cut these, we cut them in the bandsaw. So this is our bandsaw. It is it's a do-all 36-inch throat. I think it was built in the late 60s. This one has a variable speed. This is just a really nice machine. This was I think the second piece of equipment I bought. The first one was a forklift so that I could unload this thing, but this has been the staple of our shop. It's probably the most important tool in our shop every day. Generally we run a 1/4 inch blade, and I think it's a 18 tooth. All the tube we use, I didn't talk about that earlier, but this is all 16 gauge tubing. You can use 18 gauge, it's a little thin. 16 gauge definitely holds up better for headers. You always need at least 2 teeth in your metal at once. And so an 18 tooth, that means there's 18 teeth per inch. So if you do the math, if this is 1/16, that means that there's actually 2 teeth in it at all times. You want to keep your bandsaw nice and tight, and keep your guides nice and tight on your blade. A 1/2 inch blade probably works better on exhaust. We keep the 1/4 inch in there all the time because we're doing scroll cuts, and it's a lot to change out every time. Also, you want your guides. You want your guide as close to your tubing as you can get. When we mark these, I know there's a lot of different tools out there to do different angles and ways to mark it. We'll be showing some ways I do it. I don't take the time to do all that because I like to be fast with it. And a lot of times just my eyeball works better than anything. So to get started on building these headers, first thing I'm gonna do is I already got the flanges bolted on. I just put 2 bolts in them, in each one, and just snugged them. I don't wanna keep wrenching on it and get them super tight, but we do want it flat to the head to get everything mocked up. And I'm gonna go ahead and put some spark plugs in here, and I have some boots. We're gonna actually make up spark plug wires for this, for the coil on plug, and we're gonna mount our coils up here on the front bars for the frame. And I wanna mock it up and put the boots on there so I kinda know where they are. And the more you can do to figure out where you want to route your tubes, the better. And these spark plug boots will help me do that. So I'm gonna put some plugs in here. So the first thing we want to do is we want to figure out how we're going to come out of the head, and we kind of want to start this one is the furthest away from our collector, so we want to keep it kind of as straight as we can, and then from there we'll start curving them more and more so that they kind of come out as an equal length. The more equal length they are, the better they're going to flow in sync with each other. So we have our 2 different radiuses that we can start with here. Preferably, you want to go with a bigger radius. The less it has to change direction, the less energy it takes to change that direction. So you're just conserving energy all the time. So, and we have plenty of room in this Nova the way it's laid out. So we want to come out, kind of straight out of the head here. And we'll kind of position. Maybe we'll take this one out. Actually, these back 2, we might even have to go to the short one. In fact, that might work better. We'll do the short one so we can get around our steering shaft. And maybe we come out a little bit and then angle it another direction. There's so many things we can do. These work so well to mock things up and figure out where we're going. And we'll kind of do it and tape it all together and make it happen. So another little tool that we use is this collector template. It shows where our 4 tubes need to come, and we want to do that under the car. We want to mount that under here so that we know where our collector needs to end up. That way we can kind of fit our tubes into this piece. So we'll hard mount this to the car, and we've added this piece of tube on another job, and I might have to cut that off, but we'll figure out how to mount this where we want it. So let me grab a collector. So the collector, I kind of want to figure out where to position that. Preferably we want them kind of coming back straight and not hitting anything. So I think probably right in here somewhere will be good. Maybe here, kind of right where the floorboard starts going up. That'll give us enough room to get all the tubes down. It'll probably be about 30 inches long, each tube. I'm just kind of guessing from previous jobs. And we'll have enough room here for our V-band. I'll talk about the V-bands later. One thing I like to do is make sure that my collectors are even across the car so that they're in the same position. So I will go through and mock all this up, get my tools. I don't even know what to call these, but it works great. It's the same shape as the tube, so all 4 tubes fit in there nicely. And we can take them in and out as we're fitting it, and then when we're ready to tack them, we tack weld them all.
Now that might feel like a lot of lead up and planning before even sticking 2 tubes together, and it is. But building a custom set of headers is no simple task. Let's just say it's not a Saturday afternoon project. Remembering that fact, and the fact that he hired employees specifically for fabrication tasks like this, Paul decided to bring Nick in to actually build this set of headers. So, Paul got back to work on the other 36 things on his to-do list and let Nick take it from here. For a little more context on the car, this 1967 Nova was a running and driving street machine, complete with a supercharged 383 small block and an automatic transmission. It didn't put down as much power as you'd expect. And it certainly didn't have the drivability its owners wanted. So to fix that, Paul ordered up a 525 horsepower LS3 crate engine and a Tremec TKX 5-speed to not only make the car more fun to drive, but put even more of that power down more reliably. And spoiler alert, it worked.
Yeah.
With all the tools and materials ready to go, Nick got to work. Nick called Brandon over from time to time while working out the details on the driver's side, just for another set of hands and to get some pointers on tube layout and TIG welding. After a couple long days, the driver's side was tacked together and he was ready to move on to the passenger side. He started by bolting on the 2-piece flanges and mocking everything up. The goal was to keep each of the 4 tubes roughly the same length while maintaining a sense of cohesiveness. Nick also had to take into consideration accessibility of the motor mounts and the starter. One of the most crucial aspects of TIG welding stainless tubing is to make sure the cut is square and the edge is completely smooth. Nick uses a disc sander to get the cut as flat as possible before deburring the inner and outer edges. He even takes the time to scuff the tube with a red Scotch-Brite pad to give it a smooth and cohesive surface. Then he does a final cleaning with acetone and a clean rag to remove any oils or impurities from the stainless steel before welding. After fitting up 2 sections of tube, Nick makes a few marks across the tubes. This helps him line them back up perfectly when he goes to tack them together. Once it's time to start welding out a section of headers, he sets up the tubes so he can purge his welds. What he's doing is filling the inside of the tubes with gas to protect both sides of the weld. The benefit of TIG welding stainless steel is the welds will hold up better over time and not rust. But without purging the tube, the inside of the welds would be exposed to the ambient air. They'd be less pure and more prone to corrosion over time. Nick uses a second bottle of argon to feed gas into the tubes and seals it using painter's tape. On the other side, he stuffs the pipe with steel wool. This causes a restriction in the pipe to hold in the gases, but still allows some flow so the ambient air can be pushed out. Once the weld is complete, Nick cleans it up with a wire brush to give it a more finished look. With all 4 tubes welded out, Nick moves on to the collectors. He cut all 4 tubes to length and then fits up the little merge bullets and tacks them together before welding them out completely. Then he welds the reducers to the collector as well as the flange for the V-bands. He'll wait until the headers are back in the car and he can start planning the rest of the exhaust before finally welding on the collectors. To this point, the primaries have just been tacked to the flanges, but it's time to finish welding them. He sets the headers up on an old cylinder head to make sure the flanges can't warp, then uses a small piece of welding wire to hold the exhaust valve open just a tiny bit to allow gas to flow through when purging. Brandon comes back over to run the first weld and make sure everything's set up right. Then Nick goes ahead and welds them out. The last step is getting those collectors welded on. Nick mocks up where the exhaust and the mufflers will route, since the collectors have some wiggle room when lining up the outlet. And just like that, this LS swapped 67 Nova now has a completely custom set of TIG welded stainless steel headers. The big secret? It took about 7 days of work to fabricate. And that's pretty normal. Sure, someone could throw together a set faster, but there's also plenty of times that it could easily take twice as long, depending on the application. The combination of time and materials means headers like these aren't cheap, but that's also what makes them so cool. Plus, they'll probably outlast the car itself.